Okay, another little video clip. Propeller performance charts. So we've got these non-dimensional parameters. So when you do a calculation or a measurement of a propeller performance, you will then reduce the data into the non-dimensional coefficients that I've already mentioned and that are in the notes. And you present them as propeller performance charts or tables or something like that. So let's just consider what we've got. So you plot typically something like the thrust coefficient as a function of the advance ratio, and at zero advance ratio, zero flight speed, you'll have a high thrust coefficient, and it will then drop as the flight speed increases, and eventually the thrust coefficient will become zero. You can change the value of the thrust coefficient by changing the pitch angle. Okay? So what will tend to happen is that the thrust coefficient might behave something like that. That will be beta increasing. So for a given propeller, you will see propeller performance charts, say for example for thrust coefficient as a function of advance ratio for a range of pitch angles of the propeller. So this helps a propeller designer choose the design of propeller that they want for the particular application that they've got. So that's thrust coefficient. An interesting one is the efficiency. So again, you want to choose a propeller to operate at a high efficiency. So if you take all the performance data from the propeller and calculate the efficiency, plot as a function of advance ratio, then you might get a curve typically like that. Obviously zero efficiency at zero flight speed, it's not generating any useful thrust power because it's not going anywhere. Efficiency then increases to a maximum, and remember from the propeller thrust coefficient that the thrust drops quite rapidly at high advance ratio, so the efficiency will also drop to zero, and so at a certain advance ratio we will have a zero efficiency. So it would be nice to choose your propeller your actual propeller operation point as being somewhere like there. That's for one advance ratio only. Remember, the advance ratio is a non-dimensional flight speed divided by propeller rotational speed times diameter. You change the advance ratio, you move elsewhere along that curve. You would like to vary. Remember, you can vary the blade pitch if you can. If it's built into the propeller, you vary the blade pitch to choose an optimal operating point across a wide range of advance ratios. So at a different advance ratio, the performance chart might look like that, and so on. So that would be for increasing beta. So what you do with a variable pitch propeller is that the propeller pitch would vary according to the advance ratio to keep the efficiency high. You might as well convert as much of that applied propeller power into useful thrust power as you can. So we have these propeller performance charts typically showing data like this. So look again at the notes. Okay, thank you.